When I was in class 7 or 8, I think, I was taught how to find the HCF of two numbers using this method called prime factorization. Now, I could do it, I could get the answer, but the trouble that I had was that I didn't really have a good explanation for what I was really doing to get the answer. I didn't have a good visual in my head as well. So what we'll do here is let's really dive deep into understanding what the HCF really is and why writing prime factors actually helps us find the HCF in an easy way. Now, a good way to understand anything is to start with a simple example. So let's imagine that we were asked to find the HCF of 12 and 18 using the method of prime factors. So then what's the first step that you'll think about? Like, what's the first thing you need to find out? The first thing is to ask, hey 12, what are the building blocks that make you up? In other words, what are your prime factors? And there are many ways you may like to find it. I may do something like this. I'll just write 12 and I think it's called the factor tree drawing. So it's 6 here and then 6 is not a prime, so 2 and 2, 3. All these are primes. So I know that 12 is made up of 2 2s and 1 3. So maybe I can just write it here, 2 2s and 1 3. That's what 12 really is. And then I can do the same thing. I'll go to 18 and say, hey, what are your prime factors? And there's a way to find that as well. 18, 2 goes and then there's 9 and there's 3 and 3. So 2 into 3 into 3 will give me 18. So 2 times 3 times 3. So 2 2s and 1 3. Here it's 1 2 and 2 3s. Now, before you jump into any method that you're already aware of, pause for a moment and think, what do you need to do next to find the HCF? What is the HCF really? Just think about that. I have a picture in my mind because the moment I know this, I visualize 12 to be this circle that's made of, basically this is 12 and the building blocks are here, 2 2s and 1 3. And I imagine 18 to be this other circle which has 1 2 and 2 3s. Now the question to ask is, if this circle can be imagined to be 12 and these are the building blocks, this is 18 and these are the building blocks, then what's the HCF in this picture? How do you visualize it? Pause for a few minutes if you need to and really think about that. Because if you ask me, I'll say that asking what's the HCF here is exactly the same as asking if I'm only allowed to use those building blocks that are common to both 12 and 18, what's the biggest number I can build? Do you agree with that? Then let's see what are the common building blocks. Let's just go there and see what are the common building blocks. You'll see that there is 1 2 in common and 1 3 that's common, right? You can see that right away. So then you say, okay, what are the common building blocks? One is 2 and the other is 3. Then the biggest thing I can build with them is 2 into 3 or 6. So 6 should be my HCF. HCF equals 6 for 12 and 18. But now would be a great time to pause and ask, hey, how am I really sure? Why is it that taking all the common factors and multiplying them gives the HCF? Why should I take that for granted? Why should I believe you? And if you ask that question, that's great. And the answer to that I have is that HCF basically has two jobs. Okay? The first job is that the HCF needs to be a common factor. It needs to be a common factor. To be a HCF, it first needs to be a CF. Now, anything you take from this region, right? If I can shade this region, anything you take out of this region will be a common factor to both. Because that's why there is an overlap here, right? This 2 and 3 are part of both of these numbers. So whatever you do, multiplying any of these numbers within this, whatever you get will be a common factor. Now you may ask, wait, I know 2 is a common factor. I know 3 is a common factor. Why should multiplying them together also be a common factor? And that's a great question. Think about it. If a number is divisible by a number, say 2, and by 3, it will also be divisible by their product. So anything you do within this, any multiplication you do, that will also be a common factor. So 2 into 3 will also be a common factor. But the HCF has another job. It's to be the highest of these common factors. The highest of these common factors, the H part of it. So if something is H and CF, then it's the HCF. So how do I know this is the highest? Think about it. 2 is a common factor. So if you've written 2 as an answer to the common factor, you're right. If you've written 3, that's right. But 2 into 3 is the biggest thing you can form with given these set of common factors. Only 1, 2 and 1, 3 are there. What's the biggest you can form with it? The highest. That's 6. So you're guaranteed that if you take two numbers, let me for a moment just take this 18 out over here again. If you're guaranteed that if you have this 18 somewhere over here, if you bring them together and if you look at what's common, then you can forget everything else that's not common. They can never be contributing to your highest common factor. Then only look at what's inside, multiply all of them together, you get the HCF. So now you have a picture for HCF. We've seen one example. Let's see one more. Let's get rid of all of this and maybe take two numbers, 120 and 84. And let's find the HCF of both of these. Now I know that you already know how to do this, but pause for a few minutes and draw the diagram like we did for 120. Put all the prime factors inside, draw the diagram for 84 and notice what's common and multiply them together. I'm going to do it now. So 120 basically has 3 2s, 1 3 and 1 5. So this is how the diagram will look. So a short way of writing that will be 2 cube into 3 into 5. Now 84 will have a similar story. It has 2 2s, 1 3 and 1 7. So 2 square into 3 into 7. So this is the prime factors way of looking at 84. Now you know that finding the HCF simply becomes put the two together and count how many common factors are there or what the common factors are. And the moment you do that, you know that, oh, so these are my common factors. 2 is a common factor. There's another 2 also is a common factor, 3. So you can multiply anything you multiply within this will also be a common factor. So 2 into 2 will also be a common factor. 3 into 2 will also be a common factor. In other words, 4, 6, all of these will be common factors. But the highest common factor will be if you take all of them and multiply them together. And that will be 2 into 2, 4 into 3, 12. So the HCF will be equal to 12. Now you have a really good picture for why taking all the common factors and multiplying them all together gives us the HCF. But the best part is that now you can relate this to all the methods you may be already used to. You can look back and do that. Now one of the methods that I was used to is to say the HCF, you should just look at all the prime factors that are common and take their minimum powers. So one factor that's common is 2, minimum power is 2 squared. Another factor that's common is 3, minimum power, in this case both have 1, so both minimum and maximum is just 1. 2 squared into 3 is your HCF, which is exactly 12. Pause and think about how you've done exactly the same thing. You've taken the common things and written it exactly like over here. Think about that. Another method you may be used to is something like this, where you have taken the two numbers, drawn a line like this, drawn another line like that, and then taken all of these. So now think about when you're doing this, what you're really doing is exactly the same as what you've done over here. So whatever you're doing, you've always been doing exactly the same thing. And I hope now we have a better picture for it. Now if you're really curious, you can draw more diagrams like this for 3 numbers and notice that there'll be one more circle over here, which means that some of the factors will be common to all 3 numbers, which is what we'll take out as the HCF. Another interesting thing you can do is ask, if I can visualize the HCF this way, then why can't I visualize the LCM also this way in a diagram that's like this? And the answer is you can. We'll cover that in a different video.